Welcome everyone. Welcome to our webinar, and it's great to see such a big crowd. We'll keep it going, and there's a lot to get through. So I'll ask Barry Bambury from D6 to kick off some of the findings there.
Hi everyone, my name is Barry Bambury. Some of you might know me. I'm operations manager here at DC6. For the past 6 months or so, I've been working on the energy master plan for the guys in the steering committee mainly, but really it's for the whole community. We've been learning a lot over the last few months, and we're here tonight to share with you some of the things we've learned. I think you'll all find them very interesting because you're all in the sector. So I suppose just to give you a kind of a summary of what we're going through tonight, the first thing we'll be covering is the energy baseline. So you might remember after the last time we did a Zoom call, we asked you to fill out a questionnaire. So thanks a million. I think we had a massive response in the number of people that went ahead and took the effort to fill out the questionnaire. So thanks for that. So that enabled us to get an idea of what the total energy consumption of the community was, and what portion of that was down to electricity, or what is oil, what's gas, what's diesel. So that was great to get that picture in our head to start with. It also gave us an idea of the type of different farms and the types of different technologies that were out there. So that gave us a good grounding of where we are today and where we might be able to get to in the future with a few simple applications, a few new technologies. So that was really great. And it was from the people that filled out the questionnaire. Then we picked out 5 farms from those results that got an energy monitoring system installed. So as part of the day job in the company I work for, we deploy energy monitoring across different businesses. But for part of this trial, we deployed it specifically within the community. So we've monitoring installed in actually 9 sites in total on the peninsula for the last 6 months or so. So we've gathered a lot of information about how the different, I suppose, energy users within the parlour, within the farmhouse, consume energy, just to get an idea of where efficiency gains might be able to be made and what kind of technologies might be suitable for deployment. So very interesting results from that, I'm sure you'll be interested in. And the second part then was the energy audits. That was me physically going out to site and actually looking. It was great to go out and see the dairy parlours, but to go out and look at how we might be able to improve the existing equipment there, to kind of optimize it, So that was interesting and a kind of great part of the project that I enjoyed, something different that I thought I didn't see myself doing when I left college. That was pretty cool. After that, then we'll be looking at what kind of technologies you might be interested in going ahead and installing in your farm in the near future to improve your energy efficiency and reduce your energy bills. And we'll be kind of giving you an idea of what kinds of technologies might be suitable for particular types of farms. We'd like a kind of a menu to be available to you. Then I'll touch on microgen. So microgen specifically, we'll be talking about mainly solar tonight. There'll be other technology that is appraised in the final energy master plan. So I'll go through solar PV across different scales, from the small right up to the very big. A huge opportunity here now that you're about to be established as a community. So I'll explain that as well. And finally, we'll be talking about the impact. So if you go ahead and do this, what sort of an impact will it actually make to your total energy demand? Euros, we're obviously very interested in that, and as well the amount of CO2 you'll be able to offset. So the impact you'll make to greater society, which will be kind of a great news story for dairy. So yeah, I'll kick off now if that's all right. Yeah, perfect. So we went through this last time, but I suppose, in case anyone doesn't remember, it's been a long time. What is energy master plan? This is the thing the boys are doing, right? So the purpose of the energy master plan is to start the conversation. That's what we're doing here tonight, about energy in dairy farms in West Kerry and the transitions required to a low carbon future. And I suppose, hopefully, after this project is completed and the report is shared publicly, we'll gather interest much wider than West Kerry. So I think, as some of you may know or you might not know, this is the first energy master plan, the first SEC for particular to the dairy community. So very unique and great potential for growth and a great area for opportunity. So as I mentioned, so it's kind of a 3-step thing is where are we today? I've touched on that already. Where are we headed? We'll be helping you out with that and advising you on the best steps to take, and how do we get there? That's kind of the most interesting part. Do I do this or do I do that? We'll be kind of helping you along that journey with the report. So it's kind of a 3-step journey, this SEC journey. You learn, you plan, you do. You should kind of apply that to every part of your life, really. I'd say it should be iterative. So at the very start, we're at the learn stage. That's when we were gathering all the information. That's where most of our work has been happening today. So we'll be able to share some of these findings with you. So this is the energy baseline I'm about to share with you. This is the breakdown of energy use within the community. All right. So here it is on the screen there now. So we got this based on the consumption figures you've shared with us from the people who responded, and then scaled it up to what it looks like across the community. So the biggest consumer on the peninsula or within the community is actually tractor diesel. Electricity and oil are probably combined just as much. Very small amount of LPG use and very small amount of natural gas use. So what we're seeing is the heavy oil use there we're seeing is mainly down to not so much the heating of water to clean out the milking apparatus, more so to heat the dwelling house. A lot of the houses within the community are pre-1979 on oil, so very large heating demand there. And the electricity then there is a large portion of that is down to the different milking technologies that are used on a daily basis during the summer. All right, so this is all in megawatt hours. These figures are probably not familiar with dealing with. So the reason we bring things back to megawatt hours is because how do you compare a litre of diesel to a cubic metre of gas to a kilowatt hour of electricity? We bring it all back to megawatt hours so we can compare apples to apples. All right, and so the total energy demand of the community is just under 8,100 megawatt hours. Probably means nothing to anyone, but hold on, I'll give you a kind of a better feel for it. So if we look at it in CO2 I think is going to be the currency of the future and how we measure these things and our improvements. Again, you'll see the total CO2 production from the community is almost 2,200 tons of CO2, and you've been asking like what is that? So like when you have a tree, as I say, a tree always consumes only 22 kilograms of CO2 every year. So you need almost, what's that? It's I think I have written down here. Is it 10,000? Yeah, 100,000 trees to offset the amount of CO2 produced by this very small community, considering the scale of dairy in Ireland. It's a huge amount of CO2 emissions, but where you have big emissions like that, you really have a huge opportunity. You know, if you can reduce that any few percentage points at all, you're making a massive impact in the overall CO2 emission of Ireland. And I suppose the figure is probably the headline figure that you both most be interested in looking at is the euros cost. So we estimate that the total energy spend of the community is almost €750,000. So, you know, a very small group of people, a massive amount of energy spent every year on electricity. So again, like when you have a big figure like this, all the technologies we're looking at deploying, we'll be looking at reducing this energy spend. So I think that's some very interesting figures there. So that's the first step for us when we begin this process, is looking at this energy baseline. So within the questionnaire as well, we asked you some specific questions about, like, to get a feel for what's happening on the farms, or what have we physically going on in these homes. And I just some interesting ones here. You might be interested in them. I'll rattle through them. I won't spend too long. So the only micro generation within the community is solar thermal, 2 instances of solar thermal. So no PV. I wouldn't really even consider solar thermal microgen. Solar thermal is used just for heating hot water, whereas PV is photovoltaics. That's the solar that makes electricity. So we have 0 instances of solar PV within the community, which is quite interesting when you see the massive amount of electricity that's being used, and you see the fact that 43% of the parlours in the community have south-facing roofs. That's very interesting right away. Huge opportunity there. When looking at other types of microgen, almost half the farms on the peninsula have streams passing through them. So that's a kind of a feature that's a bit more unique to West Kerry, I'd say, than the rest of Ireland. What you need to harness the power of the stream is you need a good head, you need a fall of land, and you need a lot of water. We've both of those things around here. So specifically to this area, huge potential for microhydro, and we'll be covering that a bit later as well. We've an exact 50-50 split between standalone and shared connections. And this becomes interesting when you look at things like solar. So what I'm saying is here, half the homes share the connection with the parlour. The other half have 2 separate ESB connections. We'll be covering why that's interesting in a while. As I've already mentioned, half the farms are pre-1978. One of the interesting things of the people who filled out the report was that most people either didn't have their BER to hand, their building energy rating to hand when they were filling out the questionnaire, which is fine, or else potentially they didn't know the BER of their home, which, you know, we're actually unsure which was which. So either way, more than likely, you know, these homes, there's a large energy consumption per meter squared of a home of this era, unless you go ahead and do significant retrofit. But again, where you have weaknesses like this, it's a huge space for opportunity to improve. 98% of the farms use the plate cooler. absolutely every single farm should have one of these. They reduce the consumption in your bulk tank by about 50%. It's a no-brainer really to have one of those in the parlours. That's a must. 8% of the parlours have heat recovery. I suspect it's actually slightly lower than that. Knowing the people who filled out the questionnaire, knowing what's out there, could be even lower. Heat recovery is really interesting technology, great potential. 48% of the parlours heat hot water using electricity, which was great to see. I was surprised to see it that high. Night Saver electricity competes just as well with gas, maybe even better. It's very, very close in terms of kilowatt hour usage. With electricity, you don't have to service anything. And electricity is getting greener and greener in Ireland as we add more and more wind to the system. So electricity really is the fuel of the future when it comes to decarbonising. 29% of the parlours have variable speed drive pumps. We'll be touching on them and the performance of them a little bit later on as well. It's quite a significant figure to have them, so it was interesting. A lot of the parlours have LED lighting, which I was delighted to see, because LED lighting, it's cheap to deploy compared to some of the other things, relatively speaking. And with the monitoring, we saw relatively low LED lighting consumption up until the last few months when people were milking, and they actually needed lighting to work. And we saw a big ramp up in the lighting consumption. So that's very interesting. And as well, people who have security lights and stuff outside, these are constantly on, big consumers. So final one there is 52% of farms are pumping well water. So this is one that kind of blindsided us that I didn't think of. Depending if you count the supply, you get your pressure, but if you're pumping well water, that's energy you're putting in the whole time. And it can be a very significant energy user on the farm. So big thing in that is to watch out for if you're pumping the water, or either way, you should be definitely watching out for leaks, because you don't want to be putting energy in to move this liquid somewhere and then it goes off somewhere else and does its own thing. So that's kind of just a list of insights that we have from the questionnaire. So as I say, once we completed the questionnaire, we got the results in the questionnaire. We picked out the farms for the energy monitoring, installed the energy monitoring. I suppose I can share some of the stuff we learned from it today. So here's a breakdown of the different. There's 9 farms in total on the peninsula that have it installed. We have a good mix, so we tried to get a good mix of herd size. So you'll see that we have some very big, very small. Cooling technology, we wanted to look at the ice builder, we wanted to look at the bulk tank with the direct exchange. And then the way of heating the hot water, we looked at multiple ones: oil, gas, Night Saver. Everyone should be on Night Saver. If you have a parlour and you're heating hot water with electricity, I was surprised to see there's a significant portion that weren't using Night Saver. So like, if you don't know, Night Saver is half the cost of your day rate electricity, essentially. Like, so it's you do get a slightly higher standing charge with the amount of water, with the amount of energy you're using. It easily offsets it. Like, so Night Saver is a real no-brainer for anyone that's heating electrically. It's the way to go. Vacuum pump, variable speed drive vacuum pump. This is one of the ones that was kind of interesting to look at. We got a mix here of have and don't have, so that was interesting. ESB connection, standalone, our share. We got a touch on that already. And we also have a farm with a robotic milker as well, which is quite interesting. We got one of them as well. All right. So I can share with you some of the results from before we get into that, just to give you an idea of the energy breakdown within the parlour itself. So we installed monitoring, and we wanted to get kind of, just like we did at the community level, we wanted to get an idea of where was the energy flowing within the parlour. And so milk cooling is the biggest consumer, followed very closely by water heating and by the pumping of the milk as well, the milking process itself, the 2 main ones. Water pumping, as I say, can vary drastically depending on the farm, and then other. So we're seeing that other figure is starting to creep up as the milking becomes less and less. The cooling requirement is less and less. It's colder, there's less milk, so the bulk tanks aren't working as hard during the day. But there's other stuff going on at the farm. Scrapers operating. I know we touched on it a lot at the last meeting, and that other figure now is becoming a bigger piece. But so hopefully we'll have an opportunity to dig into that a little bit for the final part of the project. It's looking to be significant enough as we move into winter. Okay, so here are some of the results. The lads were always on to me. They wanted a single figure for the energy monitoring. What's this farm? Where does it rank? Is it top of the class or bottom of the class? It was very hard to do that for the whole farm. There was too much stuff going on in the background. This other figure was messing it up. So what I did is I broke it down. I gave them a rating based on the technology. How's that technology performing against the other ones? So the cooling energy demand, this is how hard the bulk herd is working. I had to normalize everything up to if it was 100 cow herd size, so we can compare farm to farm. So this is quite interesting. So we did it for what is typically, do we see the 24-hour consumption of the bulk tank if it was 100 cow farm. what is the kilowatt hours of a single wash. Some farmers are washing more or less. I think it depends on how often the milk is being collected. What's the energy demand of that? And then the vacuum pump, does the vacuum pump work? Does it make a difference? So what I've done here, I won't spend too long on this. Anywhere there's a green number is where there's a energy efficient product has been deployed. So if we start on the right to be awkward, you can see the two guys with the green. So anyone that's underlined is the best score. Anyone that's greened is a kind of a renewable technology. So you'll see on the right hand side, the variable speed drives, there's two of them. They performed significantly better. We saw a big difference in the fixed speed, from a good to a bad. There was a big range. So you'll always see variable speed drive, all the documentation I read, all the reports, it's always 60% more efficient. Definitely can be. It can actually be more. But there's just a big variance we were seeing in how the fixed speed motor, potentially to do with the sizing of it or whatever. Just an interesting finding from it. I'll swing on to the cooling I'll swing on to the heating technology first. So the heating technology, the two ones in green are ones that have heat recovery installed. So you're essentially halving, maybe even more, maybe a third almost of your existing heating bill if you get heat recovery installed. So it's a massive reduction in the amount of energy required to heat. So anyone that's not familiar, heat recovery works. It recovers the heat off the compressor on the bulk tank, scavenges that heat and stores it. Heat recovery has massive potential. The biggest challenge with it is it's if you could actually, you're not milking, you're not washing every day. Sometimes you have too much water and then the demand comes on. There is a potential there if you had a parlour, in theory, close enough to the house. Could you heat the hot water in the home as well, or could you use it? Could it be if you go to air to water heat pump, could you use that to supply that as well? So there's potentials there to harness this heat in greater ways, but even when we see it applied to its existing guys, we're seeing very significant improvements. So what you see then is with the heat recovery that's been installed here, we've been talking to the lads, I think it gets it up to 55 degrees or so. I think about right, 55 degrees or so. There are newer versions of heat recovery available that will get it up even hotter. So what the guys do with heat recovery is they use the free heat to heat it up that far, and then they boost it themselves, be it with electricity or gas. But now we're seeing technologies that are out there that will get it that extra 20 degrees. We need to be at 80 degrees for hot wash. It will get you very, very close, if not all the way there. Cooling demand, this is an interesting one as well. It's interesting to see the one with the best cooling demand was the one that had a vacuum pump and the heat recovery. So there's a couple of theories we have in this. We're seeing definitely good performance with the vacuum pump when it's coupled. We're seeing the vacuum pump is definitely increasing the performance of the bulk tank. It's not like it is improving the performance of the bulk tank, but not directly. What we reckon it's doing, and what I've seen it doing, is that the vacuum pump enables the variable speed drive vacuum pump enables the plate heat exchanger to potentially work more efficiently. So that's our assumption. We can see it in the data. Our reason why is theory so far, pumping it through at more gradual pace. So it's giving the heat exchanger an opportunity to work better. As well as that, you will see, if you have heat recovery as well, you should see a slight improvement in the coefficient of performance. That's how efficient the compressor and the bulk tank is. You should see a little push. So we're seeing that in general. The bulk tanks perform very similar here. That was the main lesson from this one. There's not a huge variance in how the bulk tank performs. Customer I there at the bottom actually had an ice. He's probably the only outlier. So that person actually was building ice at night time. So that technology is there. So even though their overall kilowatt hour figure is probably a little bit higher there, it's also night rate electricity. So it's a much cheaper form of energy. So that's something to keep in mind. They get good value for that morning milking. Now it's no use to them, or it's less use to them in the evening. These are just kind of interesting learnings from when we broke it down step by step, and this kind of helps us in our head when we're trying to appraise these technologies in the future. Like we always see, like, how does the variable speed drive heat pump, how does the variable speed drive work? We can see it for ourselves here. It does perform. Heat recovery does perform. This gives us kind of more confidence in recommending it to the community members. So that was just some interesting stuff. I kind of lost track of time. I hope I'm going okay and not going over it too much. I think I've gone over nicely. So yeah, these are the headlines there. Variable speed drive, 30 to 55% less energy than fixed speed. Best performing bulk tank, I touched on that already. Heat recovery, 60% less energy in heat, a night saver. Covered all these. Yeah, the LED lighting, I mentioned that already. It's €1 to €2 today. We're seeing it at €2 per day is what we're seeing at the moment in some of the bigger farms. It's a big increase from what we're seeing during the summer. Put a figure on the pumping water. Some people are spending €2 a day to pump water, very, very high amount of euros. And the scraper time, we touched on that already. And as you come into this time of year, it's just worth remembering that message we shared with you last time. Make sure you're happy with the quality, first of all, but if you can hone it back, they're very, very hungry items. So if you can hone them back at all, you make instant savings, The audits. So now I'm going to talk about the energy audits we called out of the farm. It's just kind of an interesting one. So we'll talk about the plate heat exchanger. So the goal of the plate heat exchanger is to have at least a 3-to-1 flow rate. So 3-to-1 water compared to milk. That's kind of what you should be aiming for. Most of the time you can't measure that. So a kind of a good indication is if you can measure the milk as it goes into the bulk tank. 18 degrees Celsius is good, 15 degrees Celsius is excellent. So it just means there's less and less work for the bulk tank to do and to bring it down to that 4 degrees Celsius. I think you can the performance of the plate heat exchanger then, depending on the number of fins. More fins means it's better at getting it down. So you should be trying to aim for 18 is okay, 15 is pretty good. Energy efficiency of bulk tank or ice builder. So anytime you have a heat exchanger, that's going to be, this is this thing in the bottom right hand corner here. You've probably seen it yourself 100 times. That's trying to push out heat, so you're generating cold in, be it the bulk tank or the ice builder. This thing is trying to get heat out to the environment. It's sucking heat out of the milk and it wants to get it out to the environment. So it does this with these very, very thin metal fins. But these fins, if they're maintained better, if they're clean, they'll get rid of that heat easier. If it's got a bit of dirt on it, that's like an insulator on something that's trying to push out heat, and the compressor has to work that little bit harder. So, and as well as that, located in a room that isn't very hot. You know what I mean? So a compressor, it's all about having the smallest difference between the hot and the cold. So you get a compressor to work more efficiently. If it's got less, the harder it has to work, the more efficient it is. So by placing it in a cold location that's well ventilated, you'll get better performance of your heat exchangers. What am I talking about here? Oh yeah, water heating. So insulation, this is everything you're heating or cooling, actually, really. Anything that you want to keep hot or cold, should be well insulated. You don't want to leave that energy escape to the environment. I suppose naturally over time things come loose, small bit of maintenance, make sure it's, you've gone to the effort of putting it on at the start, just tape it up, keep it nice control. And the final picture there that I'm trying to show you, and I know it's very hard to fix these things, is the location of the equipment. If you're heating water to clean out the bulk tank, if there's a boiler, gas boiler or electric immersion heater or whatever it might be installed purely to clean the bulk tank, make sure it's located. In this instance, it was extremely close. Make sure it's located near the bulk tank so the hot water has the lowest overall distance to travel, and you reduce losses that way. Okay. Compressors and pumps for leaks. So we'll start with check for leaks. So this can be, we had a couple of farmers who were pumping water. We installed the monitoring. We could see they were using a huge amount of energy at times of the day they shouldn't have been. So they were able to figure out, oh geez, I have a water leak here and I'm pumping it the whole time. But also for air leaks. So every farm has air compressor for gates or whatever for different things in the farm. If it's coming on, you'll hear it yourself coming on at times of the day when it shouldn't be coming on due to leaks in the system. They're an absolute nightmare to change. But if you do have a clue where it is energy that you're putting in to compress the air that's just going off somewhere and doing its own thing. And then the second piece is to make sure the pressure that you're operating at is no higher than what the manufacturer recommends. If you're operating higher than you're supposed to, the air will get out of those leaks even faster. And then if you have any part of these systems, if there's any filters, you have air filters and stuff like that for the vacuum pump or the milk pump, make sure they're clean and well maintained, because otherwise that pump is just working harder than it needs to the whole time. These are all easy changes, and they're not a huge amount of effort in that. This one here is a slight water leak. Like, it's not very bad. Most of the farms are in fantastic condition energy-wise, but these are just small things to watch out for. And when you go home, just have your eyes open and your ears, yourselves. All right, lighting. I just give you an idea as well. Let's say the average farm is now using €2 a day, or bigger farms are using €2 a day on lighting. LED lighting is 40% more efficient, but it should also last about 3 times as long. So you get a way longer lifespan. So it means you, as a busy person, has to spend less time changing bulbs, you switch to LED. So they're fantastic technology. Initially in the project, it looked like they mightn't be worthwhile, if that was fair to say, but now we're getting into winter, the usage is skyrocketing. They're on for hours and hours a day, particularly if you have an outside yard light or anything that's on for a long time. Switching to LED, the whole idea is that you'd switch bulbs that have high hours of operation. You get a quicker payback in that instance. I'll keep going. So at the start, we looked at a number of technologies. Tonight I'm going to go through the four key ones that we've been investigating. We'll go through solar in particular detail there in the end. The vacuum pump, just to put some figures on it there today. So vacuum pump, typically all these prices are for 100 cow farm that we figured out. Probably a little bit larger than the average one in West Kerry, but it just makes the sums very easy for you when you're reading the report. So the variable speed drive 50% more efficient, saving €400 a year with no grant aid. I will talk about grant aids at the end and your different options. We're looking at a payback of 8 years, which is still quite attractive, but there are grants available for this that will make it even more attractive. As I mentioned already, a variable speed drive or variable frequency drive, it'll increase the efficiency of the plate heat exchanger. Apparently they're faster. I read this online. I'm not sure as there's people on the call might be able to share their experience. And apparently less noise as well. I think it's quite a different noise. Less noise, maybe it's not as nice a noise, or a less nice noise, I'm not so sure. But variable speed drive vacuum pump, very, very suitable technology for dairy parlours. And that's why we're seeing such a high penetration of them already. All right. Heat recovery, and this is the one where we're recovering the heat off the compressor. There's a little diagram in the bottom right to show you that. We'll recover up to €700 a year. We're seeing initial investment 5.5K pay. Slight improvement on the coefficient of performance of the compressor, so it'll cool your milk a little bit cheaper. Payback period is 6.8 years. We're seeing with no grant aid, but add-on anchor aid with that. Grant aid with that. There's a suite of them for you to choose on. That'll bring down that 5.5K investment, and those years will really come tumbling down. As I say already, there is the potential, if there's interest out there as well. We'll be at the end of the call tonight. We'll be sending out a questionnaire, as I mentioned, to find out what the appetite is for these technologies. There's definitely potential to look at the dwelling house nearby, particularly if there's a high, I suppose, a high hot water demand in the house. If there's a big family home or something like that, would be an ideal candidate for heat recovery into the dwelling house. LED lighting, I think I've covered some of this already. LEDs is super fast payback period, really easy to change. That's the main thing. You don't need anyone to come in. It's an easy swap. And as I say already, if you're using outdoor security lighting, switching to LED bulbs is a no-brainer. One of the things we touched on at the start was agri-diesel. Now, there are options to improve. I suppose there's a limited amount you can do, but there are steps you can make to improve the efficiency of the tractor fleet that's there already. It's all to do with energy efficiency, make sure the tires are correctly inflated and stuff like that, and make sure it's being driven correctly and stuff. But newer tractors do have a lower CO2 emissions rating. So newer tractors, as we move on, they're getting slightly better at CO2 consumption, but they're getting vastly better at NOx and particulate matter, which affect the local air quality. The kind of things we can do to improve it, it's a big challenge. Like, what do we do as a community to improve tractor consumption? One of the things is land fragmentation. We'll be highlighting that in the report. So a lot of the land, I'm learning, of dairy farmers is fragmented and around the place, and this leads to more driving, more effort for the farmer to get the cows back to the parlour, and more CO2 emissions from tractors and cars or quad bikes or whatever it might be. So the real options we might look at as a community, or one of the suggestions we'll be looking at, is biofuel or biogas. That's one of the things that could be used, and there's another project in Dingle already looking at that. So they're the kind of things we can do to approach the agri-diesel issue. So this is where it kind of gets a bit more interesting. So typically, if you're a standalone person who wants to go away and get solar panels, your only option is to put them on the roof of your house, the roof of your milking parlour, maybe if you're a farmer. But because you're established as a community, or are about to be established as a community in the eyes of the SCAI, you actually have other options that are quite exciting. So first of all, as I say, that the standard option is still there to get either, if you have a single phase connection, get 6 kV on the roof of your house, get 11 if you've got a 3-phase connection. So if you have 3-phase connections, costs about 1.5 to 2K per kilowatts. You can get grants off SCAI, TAMS, and you're offsetting the energy consumption within the home. That's what you're doing. You're offsetting the energy that you would otherwise be buying from the grid. In Ireland, we get no money for selling, or at the moment, we get no money for sending that energy back out to the grid if we can't consume it ourselves. Wholesale price is kind of, there's talk of a feed-in tariff in the region of 5 cents to come in. As of today, it's still not in. So yeah, you're trying to consume as much of that energy as you can with solar PV. If you can't consume it, you start looking at things like battery and stuff like that to harness it and use it at other times. But now that you're about to be established in the eyes of the SEI as a community, you actually have the potential to play in the wholesale market or become shareholders or project owners of a larger scale solar farm. So it could actually go down one of two streams. To play in RES, you need at least 500 kilowatts of solar named to your community. So that's the minimum size. The existing rules is that needs to be on one site. There's a lot of talk out there at the moment that they might be looking at breaking it up for the next round of RES. So the potential in Kerry, you could be looking at something like 10, 50 kilowatt sites, which would be a mix of harder, big shed mounted along with maybe some ground mounted on 10 different sites if there was appetite for that. Cost about 60 or 70 grand a site. You could consume some of it. You could export it out to the rest of the wholesale market price, which would be much better than that feed-in tariff that you'd be getting if you would just go off and do it alone. So that's kind of the message there. Or potentially you might actually go off and get or buy a part or join with a partner and enter in a single 500 kilowatt or maybe 1 megawatt site. These are big projects, but because you're established as a community, you can actually look at these options, and they're real options for you. This might seem ambitious, but other communities have gone out there and done these things before, and they have very attractive payback periods, like pension funds and private investors invest in these things all the time. So why wouldn't a community? So that's the three options. There's the rooftop, which I'll be covering as well in a minute because it's still an option. And just because you decide to go with a RES scheme doesn't mean it excludes rooftop solar. So I'll go through them now in a little bit more detail, particularly the microgen. So as I say, microgen solar, the most you can put up on the roof of your house or parlour if you have a single phase connection is 6 kilowatts. 10k investment, that's probably on the upper end, maybe with a battery in there, so maybe a little bit lower, maybe 8 or 9k. And you will generate, here in West Kerry anyway, at least, you'll generate about €1,000 or €1,100 of electricity per year, provided you don't have any shading or anything like that over your panels. But the whole thing about payback period is, can you actually use that €1,100 of electricity you're generating? You're not getting that value if you're sending it back out to the grid. So just to give you a kind of, and it's the same thing for three-phase, or it's even greater potential at three-phase. When you go to three-phase, the cost, it goes up, all right, but it doesn't double. You're doubling the amount of capacity, doubling the amount of electricity you have the potential to generate, but you're not doubling the overall investment. You get economies of scale. But again, you have even more energy, and you have to figure out, can I use that? So the trick with solar PV, it's all about right sizing is the thing. So we broke it down into three types of dairy farm to look at solar. So this is a milking parlour. I know it might look like it, a milking parlour that has one connection, and it's got the milking parlour behind it, and it's got the dwelling house behind it. So this is over the course of 24 hours. This is just a typical day I picked in September. You can see things are happening throughout the day. You'll see I think there's water being heated in this house at night time, a couple of family homes. At 8 o'clock, you can see down in the milking parlour comes on, and you can see 6 o'clock milking parlour. But there's also lots of family stuff happening in the middle of the day. So this is everything that's happening. So what we do then is we download all this data and put it into a model, and we're able to see how would solar perform here every day, what proportion of this energy would self-consume, and just for graphical purposes. This graph isn't lining up quite right, but it's nearly there. What would 6 kilowatts of solar look like in this application? Anywhere that is green with white behind it, as you can see, that's energy that would be exported to the grid and you wouldn't get proper value of. But overall, what we're seeing is if you have a shared connection with the parlour and the house has got relative amount of energy used during the day. So there's a number of people living in it, cooking and doing all the kind of things that use energy. You will consume a very large portion of the solar, and there's great opportunity for installing 6 kilowatts of solar in this application. So it's a good fit. When you look at standalone, this is actually a very big standalone parlour I'm looking at here. So it consumes up to 10 kilowatts peak load with a significant parlour. But when you layer over solar, it just misses most of that morning milking. You get a bit at the end, but just as the milking dies off is when the solar really gets going. And then for sure you'll consume a bit of there's a bulk tank kicking on every now and again, or something's happening there to use energy during the day. You'll supply that, but the vast amount of energy is being exported to the grid. So unless you had access to the wholesale markets in the form of RES, as I already mentioned, And it really wouldn't make financial sense to install PV in a standalone daily parlour. It's just the load; it just doesn't line up. You can look at installing batteries and stuff like that, but that's additional cost. The only thing that might be possible is potentially, if you have an ice bank there, is to dump that energy into that, but you need a variable speed drive and the compressor on the ice bank, because it'd be varying amount of load going into the ice bank every day. So it's a tricky one, and probably generically a no in terms of being suitable application. We had one other parlour as well, and I haven't actually mentioned it yet. So it's a big energy user, 24 hours. It's a shared site, so it's got the milking parlour and the home behind the one connection. So big energy user, and it's got a robot, so it really flattens out that energy use during the day. So you're probably all familiar with it. You normally milking happens in the morning and in the evening, but the milking part, the robotic one really doesn't kick in until 9 o'clock or so. It starts to load up, and then it goes until maybe 7, 8 o'clock in the evening. That's that big higher scene there. The rest of it is all family stuff that's happening inside the house in terms of heating, water, and cooking, and cleaning, this kind of stuff. But if you layer over solar, you see it's absolutely gobbled up in this instance. 6 kilowatts of solar in this space, you're going to have 95% self-consumption. So it's fantastic fit. What you actually have is, this instance is a single phase connection, but if you had a 3-phase connection here, you could really look at installing 3-phase if it was slightly bigger. And you just gobble up that solar, and you'd have a fantastic payback period. You'd be offsetting electricity that's at 25, or it's coming up to 25 cents a kilowatt hour. So it's better than anything you get in the wholesale market. So solar, fantastic technology. If deployed in a domestic setting, it's all about right sizing and is it right for me and my profile. And then I think I have a slide here on res. Res is it's a business investment, I suppose. As a community, you'd have to come together to have a specific amount of interest, but it is possible. And this is just an idea, just to give you an idea of the kind of the roadmap or the kind of timescales involved in getting this project lined up and teed up, if there is appetite for it within the community. So the guys established the community back in June 2021. Energy Masterplan, we're going to submit a draft the start of December, submitted fully by June, and then you go on and we get if we submit that we have an interest in these kind of projects, we get a RES advisor, and then we just go through the stage of finding a site, grid application, planning permission. We work our way through it, and you'd be looking at constructing an operation in January, December 2024. So it is quite a long road, but the potential for offsetting the community's total energy demand is massive, and it's a business investment that people in different parts. People are investing in anyway. As a community, you actually get the way this works. I won't get into too much detail. The way RES works, community-owned projects get a preferable rate within RES. You get a slightly higher rate for the energy you produce, a slightly better rate. So last year it was 104 megawatt hours. That'd be higher than anyone else is getting for renewables. It's a guaranteed 104 euros per megawatt hour that you export. You're looking at 97,000 euros for a megawatt farm. 1 megawatt solar farm would generate just under 100 grand euros based on last year's feed-in. So that's just to kind of give you a taste for that. Hopefully there's some appetite for it. The SEC journey, before I go on to that, this is my last few slides. Coming up on the hour now soon. So that's kind of in summary the findings of what I found with our analysis, with the monitoring and the auditing. But just to give you an idea of the actual impact this would make at a community scale, first of all. So moving to the variable speed drive, say 140 megawatt hours or 49 tons of CO2. So you're starting now to kind of chip away at that 8,000 megawatt hour figure. You're nabbing away at it with these simple changes. So variable speed drive, 49 tons of CO2, massive figure. Moving to heat recovery, 350 megawatt hours, 223 tons of CO2. Switching to solar, I'm saying instead of moving to solar at 100%, because potentially solar isn't right for everyone, but it's definitely right for at least 70%. We generate 400 megawatt hours, and it's kind of, and I've left out hydro now because it's kind of a big question mark at the moment. But moving to a 1 megawatt solar farm will generate just under 1,000 megawatts of megawatt hours of green electricity over the year. So that's the real way you can start to get into that total energy demand and start to get it down year after year. And so that's going to be the overall goal of the Energy Master Plan. We're going to set a realistic target for where we think the community can be by 2030 based on the existing herd size, where we think we can be by 2030 based on the interest that you'll express to us afterwards. And then hopefully by 2030 we'll be able to come back and look at this and see, did we get close to that figure, or what technologies worked, what technologies didn't work, because I think, and I want the next slide here in a minute, is the potential for this to be rolled out to other communities is really huge. Dingle or West Kerry is such a small portion of the dairy fleet or the dairy herds in Ireland. So making these changes, you can really draw down on the overall total energy demand. So I have a slide. I've actually multiplied these figures up for what it looks like if we got a national buy-in. Now this is very ambitious, but West Kerry makes up less than 0.5% of the national dairy herd. So you can see there very quickly that the size of these figures, if you were to go to national scale, it's just huge. If every dairy farm must have its own mini solar farm, solar on the roof, heat recovery, various drive, you just hammer down the total energy demand of the community. And I think these are the kind of projects that I suppose the dairy community in Ireland needs to look at. There's a lot of pressure on there at the moment about herd size and stuff like that. These are the kind of things that you can do to reduce your impact on the environment while producing milk in a sustainable way, or the most sustainable way possible. So I think that's the plan. That's the learn and plan section done. I think the next step is the do. So I know there's a lot of people that are raring to go with to go off and do their own thing. But I think the message from here tonight is you've been established as a community. I suppose once we submit the report, if you submit it to SEI and be registered as a community, there's great opportunity for accelerated funding. I haven't touched on grant aid much at all. If you stick around and become part of the Better Energy community, you can get up to 25% off on all those initial investments. Huge opportunity there. And it won't take away from your TAMS grants. So it's a massive opportunity there. And then the RES, if there's significant interest in RES, that's one that would be a really interesting one. It'll be the first community-owned project from the dairy sector in Ireland, which would be a really good news story. And I think there might be opportunity there for a segmented solar PV dispersion on the peninsula. So I think it's, once we submit it, we'll submit our report, we'll submit our findings. I think the onus then is on the community to go out and to take action as a community and as a whole, to make sure nobody's left behind and everyone's brought along on this journey towards 2030, I suppose, towards decarbonisation. So I think that's the end of my slides. I've probably done a bit earlier because we didn't have too many questions. I don't know, Jonathan, have you anything to add?
One thing on it, Barry. So yeah. We're looking at, as we are today, and if we wanted to kind of reduce energy consumption with the herd count on the Dingle Peninsula, what could we do? I suppose it looks like you could reduce anything up to kind of 30% if you were to put in those technologies that were mentioned there of the whole picture, and take to, would say, 30 to 40% of the carbon out of that.
100%. So we'll open, before we open to any questions, I think I'd just like to thank as well, thank all the farmers that allowed us to go out and visit their farm, and for everyone who filled out the questionnaire, and to the wider community, to everyone on the steering committee that helps out every week. Just a big thank you for everyone that made this possible.
Just a few words there, Barry. We need to thank our sponsors, the SEAI, the ESB, Kerry Agri, and Jove Genetics there as well. Okay, folks. Great discussion, great information, and a lot of food for thought. Again, from day one, I believe we can take care of a lot of our own emissions by working on these things. So look, onwards and upwards. Thanks to everybody for coming on.